when you think about GPS and it's available on your phone, you don't think about paying for the satellites that facilitate GPS. But somebody has been investing billions of euros or dollars in order for you to be able to enjoy the GPS positioning experience. And now that everybody outdoors has become accustomed to this capability, there's sort of this inherent expectation that because it seems to be free for me as an end user outdoors, so it probably is the same indoors.
Welcome to another episode of the Mapscaping Podcast. My name is Daniel, and this is a podcast for the geospatial community. And today, I'm lucky enough to be talking to Eric from a company called IndoorAtlas. And IndoorAtlas is using the geometric field of buildings to help solve the problem, or at least some of the challenges around indoor navigation. Hi, Eric. Thank you so much for taking the time to come along and talk to me today. Much appreciated. And the reason I reached out to you and the reason I've been so interested in this discussion we're going to have today is because you're doing something with indoor navigation. And I think there's lots of companies out there doing something with indoor navigation at the moment. It's a hot space, but you approach it, or your company, I should say, approaches it in a slightly different way. You're using the geomagnetic field of buildings. So, yeah, maybe. But before we get into that, perhaps you could start off by just giving us a little bit of background about yourself, and then maybe we could move on and talk about how you're doing indoor navigation, and we'll take it from there.
Yes, thank you, Daniel. So my name is Eric Pielen. I'm the CEO of IndoorAtlas. I've been in the company for something like 3 years, but I continue to be very excited about the technology that we are making. And like you said, it is a bit different from anything else out there.
Cool. So IndoorAtlas, already we're thinking indoor navigation. We're thinking about a map that is centered on buildings, perhaps on the urban space. How are you approaching this differently? Like I said at the top of the interview here, you're using the geomagnetic field of a building. How does that work? Can you tell us a little bit more about that?
Sure, yeah, I would be happy to. This is actually based on an invention that was made in the old university where the company sort of has its root. So in the university research, the founder of the company, Mr. Jan Haverinen, he realized that each building actually has a unique geomagnetic fingerprint. And what that means is that the Earth's geomagnetic field obviously is present everywhere, no matter where you are on Earth. But only when you have a building and this building contains some metal structures, what happens is that the metal structures will interact with the geomagnetic field, therefore creating a unique fingerprint. And what is very interesting here is that the way our technology is working is that we can actually use the standard compass chips that are available on mobile phones. It turns out that they are accurate enough to detect the minute variations in the geomagnetic field, where these variations are there due to the presence of metal structures. So thus then becomes possible to walk around in a building and to collect on every floor its unique geomagnetic fingerprint. And what you can then do is that you can actually make a map of the geomagnetic variations. And then later on, once you have been creating this map, you can actually come back to the space and find where you are based on the geomagnetic information around you and comparing that to the geomagnetic map. So that's kind of in a nutshell, the founding idea, how the company was started. And we are the pioneer company in the geomagnetic positioning using this sort of method. Then over the years, we have actually been adding many other algorithms on top of the geomagnetic field. So nowadays, we are a sensor fusion company. And what that implies is that we still use the geomagnetic positioning as the founding positioning technology. But in addition to this, we also use a whole host of other technologies using the other sensors that are available in modern smartphones. So that will include things like the accelerometer and the gyroscope, so we'll be able to detect the motion of the phone. We also use the radios on the phone to be able to measure changes in the radio environment, typically produced by Bluetooth beacons and Wi-Fi networks, for example. And we also use the barometer to detect changes in changes in air pressure, which can be used to be informed on when the user might have been changing the floors and so on. So in other words, we are kind of taking advantage of all the sensors you have available and combining them in a unique way to a positioning estimate, which is then something that one can display, for example, on top of a map to be able to have a similar experience to what people are accustomed to outdoors where you have GPS available.
Okay, you said a whole lot there, but something that I'd really like to, if we could try and clarify right from the start, is so we started off using the geomagnetic field of buildings. So every building has a unique magnetic field, and we can use that to navigate once we understand what that field looks like. Could you maybe give us an idea of what kind of accuracies we can achieve just using that geomagnetic field, just using the geomagnetic fingerprint of the building, and then what accuracies you're able to achieve once you integrate all these other sensors which you just talked about?
Yeah, that's actually an excellent question. And yeah, sorry if I kind of gave you too much information in one go there. So the accuracy that one can get with the geomagnetic technology depends on the geomagnetic features of the building. But in a typical building, what you may find is that the geomagnetic features tend to be of the size of perhaps 1 to 2 meters. And that actually is the accuracy that we are reaching. So in our technology stack, the geomagnetic technology is the one that's producing the ultimate accuracy. The other technologies are useful for many reasons, but the accuracy is really coming from the geomagnetic side.
Okay, that's really interesting. Do you need a base map as well, or is it just enough to walk through a building and map the geomagnetic fingerprint of the building? First of all, I guess, do we need a base map? And if so, where does that come from? What do we do with it? And I guess the next question is, okay, once we have a base map, um, how do we map the geomagnetic field?
So yeah, the way this technology works is that we have a couple of prerequisites that have to be met in order to be able to use the technology. So first of all, you have to have a floor plan of the building, and on all the floors where you might want to deploy the positioning. Then you have to have physical access to these premises so that you can collect this fingerprint. And third, you are going to need an Android phone where you can install our Map Creator 2 application. And this application is the one that actually is recording the geomagnetic field and therefore collecting the fingerprint. And the way that works is that in our workflow, the very first thing that you have to have is an account in our system, which is available for free. So anybody can just go and register on our website and become a developer that way. And after the registration process, you can create a venue. And the first thing in the process of creating a venue is to upload a floor plan or a set of floor plans if you have a multi-story building. And once you have uploaded your floor plans, you need to align and scale those floor plans on top of a world map so that you have the right orientation and right size of your floor plan. For this part of the process, we obviously recommend people to use accurate floor plans so that they are in scale. And once this setup phase is done, so now the floor plans are uploaded into our service and so forth, then one can go to the premises and then do the fingerprinting, as we call it, the process of creating the fingerprint. And that is done simply by walking around in the venue. And the way you do it is that you set up these what we call waypoints. So the waypoints are points that you can easily recognize in the physical world, but also on the floor plan. So, for example, if there's a pillar, or maybe there's a doorway, or a corner, something like that, something that's easy to see both on the floor plan and the physical world. So you use these waypoints as the points where between which you walk, and you simply click on the application on the corresponding waypoint. The waypoints are such that you can actually, within the application, add more, or if the ones that you initially planned to use were not good for you, and so forth. So there's flexibility there, and you also have flexibility in the way you walk between the different waypoints. The other part of your question was, where does one get these floor plans? And this, of course, will greatly depend on where you are. So the company IndoorAtlas is from Finland, and as it happens, we have a kind of a public registry where floor plans are available from the time that the buildings were first built. So that doesn't mean that they are any more accurate, but at least at one point in time, they were accurate, and they can be used for fingerprinting purposes as a map. Still, having said that, I think the more typical scenario is that there's a relationship between whoever is doing the fingerprinting and somebody who is owning and or operating a building.
Okay, so I just want to pick out a couple of points there. The first one that I noticed was that it doesn't sound like I need any special sensors for this. It sounds like I download an app to my phone, to iOS or Android. I'm assuming it works on both, and then I can walk around the building, and there's sensors in the phone are good enough to detect the geomagnetic fingerprint of the building. Is that correct?
That's almost correct. So the way it works is that if you use an Android phone, then with Android phones you can actually do the fingerprinting. Well, let me actually back off a little bit. So the fingerprinting process is something that requires an Android phone. So that's one of the prerequisites. But then later on, when you are not anymore in the fingerprinting side of things, but you are in the positioning side, so utilizing the fingerprint. At that moment in time, Android phones don't typically require any support infrastructure, but iOS phones actually do require some amount of Bluetooth beacons because Apple has decided that they don't enable applications to do Wi-Fi scans and therefore learn about the Wi-Fi or radio environment. So what that implies is that if you have a use case or application in mind where you want to support both Android and our iOS phones, and most of our use cases are like this, and then you actually have to put in a small amount of beacons, so Bluetooth low energy beacons, which are then used even during the fingerprinting process to collect information about these beacons. So we have a tool in the tool chain that I didn't mention so far, which is called the Beacon Planner, and it's a very simple tool that enables you to draw the area where you want to perform positioning on top of the floor plan, and then it gives you a recommendation on where to place those beacons, and it also gives you the number of beacons that you will need. The number of beacons in our technology is small, so because we are primarily relying on the geomagnetic technology rather than the radio technology, we only require something like between 5 and 15% of the number of beacons that some of the other alternative solutions use, whereby they are only using the beacon information for positioning. Yeah, that's an important point, that you have to have this part of the radio environment in there. And the reason, just to kind of perhaps elaborate a little bit more, so the reason why the radio environment is necessary and useful is that these days people are used to the type of experience that they have outdoors, which is that you can pull up your phone and you can pull up a map application, and you pretty much immediately will see the blue dot indicating where you are. So this is kind of the expectation level that people have. And in order to have that sort of immediacy into the positioning experience also indoors, that's something that really requires the radio positioning to be used to have the positioning there. And that's why our positioning algorithms can actually roughly be thought of as consisting of two phases, where the first phase is what we call the first global fix, and that gives you a rough idea where you are and gives you pretty much immediately in a matter of a few seconds. And that phase of the positioning is using the radio side of things. But when you start to move around in the building, then the geomagnetic technology kicks in, and the geomagnetic technology is then able to greatly improve the accuracy there. So we call that the tracking phase of the positioning experience, and that is really what gets you down to the 1 or 2 meter accuracy.
That's really interesting. I'm not sure why, but I just assumed that the geomagnetic technology was the one that was going to be the base location. I was assuming that okay, you'd get to a building that would give you the base location. I'm roughly here, and then the radio frequencies would take over and give you a more exact location. But what you're saying is it's actually the other way around. You get a much quicker base location, if we can call it that, from the radio technologies, and then move over to the geomagnetic field.
Yes, that's correct, and it is indeed perhaps a kind of a new idea to think about it this way. Our goal in terms of how one goes about installing the positioning system and deploying the technology, of course, is to minimize the amount of infrastructure to make it as easy as possible for anybody to take benefit of the technology. And so kind of the direction where we want to move is, of course, one where one doesn't need any additional infrastructure to be installed for the purposes of positioning. But due to these operating system limitations in mobile phones, we of course have to accommodate those, and that's why the radio environment is something that is, well, it's actually a combination of the operating system requirements and the expectations of users and the way that our technology is integrated there. So that kind of gets you into this situation where you get the first quick position with the radio technology, and then that improves on with the geomagnetic technology that also gives you really accurate tracking as you walk around the premises.
Now, I don't know the answer to this, but I'm wondering, so would all these problems around indoor positioning, would they be solved today if iOS and Android just opened up everything? Would we then need beacons? Would we need physical infrastructure in the buildings to be able to position accurately, or could we just do it based on geomagnetic fields?
That's a very interesting question. And I think I want to say that yes, you actually wouldn't need the additional infrastructure if the phones were designed in a way that would be optimal for the algorithms that IndoorAtlas is producing. The small issue there, or, well, it's not so small, an important issue at the same time is the management of power consumption. So, of course, what you don't want to happen is that while you are doing positioning, you don't want to be consuming a lot of energy doing the positioning. So it's a compromise between the amount of sensor reading, computation, and battery or energy consumption to find the right kind of a sweet spot where you are able to give users the benefits of really accurate indoor positioning, while at the same time making sure that the battery lifetime is maximized. And for example, what we have been developing is a set of algorithms that we can run on the phone itself, so that we don't need to do a lot of data communication for the purposes of positioning, but the computation and the positioning estimation calculations can be done on the phone itself, as opposed to requiring a lot of data traffic. So that's one of the ways that we deal with the battery savings.
Yeah, and I'm sure there's a whole bunch of complications around that in terms of working on these different operating systems. What I'm wondering here is that if I take my phone out of my pocket now and walk around my house, I will get a position. Now, I'm pretty confident it's nowhere near as accurate as what IndoorAtlas can give me, but it's a position nonetheless. Could you imagine that Android, in my case, is actually reading the Wi-Fi signals around me, reading Bluetooth signals around me, combining that with GPS, looking for the different cell phone providers I might be connected to, and giving me a position based on that anyway, doing all that in the background?
Well, it certainly is doing some of this on the background, or some of this capability may be coming from the network of the telecom operator that you are using. To keep the discussion simple, you can just think about perhaps the GPS side of things, where when you have been outdoors before entering the premises, your phone has been receiving GPS signals, and therefore your phone has a rough idea on where you have been entering the building, and this probably is the primary source of the positioning information that you could have, in your case, in your house. But let's imagine that you have a big house or even a huge mansion, and now if you enter this building, from one side and you move about there, more than small amounts, it's very likely that the GPS position that you have been given is very inaccurate. So the GPS radio signals require a line of sight, so they don't travel indoors, and therefore GPS alone is not a technology that can give you good accuracy indoors. And in fact, where this is leading to is that no single technology actually gives you great accuracy indoors. So you need to combine, or you want to combine multiple technologies and fuse them together in order to have a good positioning experience. The other comment perhaps that I'd like to make here is that the expectations that people have for accuracy indoors are completely different from what people have on the outdoors spaces. So when you're outdoors, probably the most typical use case for positioning would be navigation during driving. And in that scenario, the GPS accuracy is more than enough. But we also kind of have to bear in mind that if you are driving a car, your car is not going to be making sudden movements to any direction at any moment in time. Most likely you will be driving forward and continuing to drive forward. Also, you have typically the constraints of driving on a road. So when navigation system is calculating your position, it can sort of base the positioning estimation on the GPS signals, but also on the idea that you continue to drive on the road where you have been driving, and you have a certain velocity, so you will be, in a moment's time in a kind of a pretty predictable position, and these types of constraints help in the positioning experience. And in general, for example, in this kind of car driving use cases, the accuracy can be very low compared to what people expect to get when they are indoors and when they are walking. So when you're indoors, now the accuracy that we are providing, something like 1 to 3 meters of accuracy, actually is kind of what you expect to get. And because you can easily maneuver yourself indoors, you can take a step forward or backwards or make a turn and continue walking. So you not only expect that the positioning experience you have is something that is giving you a nice accuracy, but you also want to have a really low latency in your positioning experience there. And again, since you are indoors, you are not driving on a road at a predictable speed, so it makes the positioning estimation task that much more difficult indoors.
Yeah, I can actually think of a few other examples that might increase or make the task of positioning indoors more difficult. And one of them would be traveling up and down stairs, for example, moving different floors.
That's correct, yeah.
And you mentioned right at the start that you solve for that problem using a barometer. Is that correct?
Yes, and exactly like in the that probability and latitude, also give you the floor where you are when. And the only sort of prerequisite to this is that you have been mapping all the floors where you expect the positioning to happen. So barometer is one of the data sources that we use to detect changes in altitude and different floors. But barometer is not a device that's present on every mobile phone. So you need to be able to do positioning even if you don't have a barometer. And actually, the way it turns out is that the geomagnetic fingerprints of each floor are different from each other. So even the geomagnetic fingerprint can be alone one source of floor information. Also, the radio environment is going to be a little bit different from floor to floor. So again, what you need to do here is to combine all of these different information sources to be able to do a good job in calculating the position in terms of the floor number. And of course, you have multiple ways of changing the floor. One way is to walk the chairs up or down, but then of course you could also just take an escalator, or you might be having an elevator. So there are different ways that one can change floors, and from the viewpoint of somebody who is designing the algorithms and the positioning methods, they are kind of different from each other, and you need to recognize that these different ways exist and be able to support all of them.
Another thing you mentioned in the pre-interview when we were talking about these expectations people have in terms of indoor positioning, and again we were making a comparison to outdoor positioning, and we talked a little bit about GPS, and we talked about the fact that it's free. Well, it's technically, as of course, it's not free, but we as a user don't pay for it. We just open our phones, click a button, and we have a position. And this is definitely not the case in terms of indoor positioning. Can you talk a little bit about the challenges there in terms of wide-scale adoption of indoor positioning?
Yes, exactly, and it stems from the fact that when you think about GPS and it's available on your phone, you don't think about paying for the satellites that facilitate GPS. But somebody has been investing billions of euros or dollars in order for you to be able to enjoy the GPS positioning experience. And now that everybody outdoors has become accustomed to this capability, there's sort of this inherent expectation that because it seems to be free for me as an end user outdoors, so it probably is the same indoors. So for companies like ourselves who operate in this space and are providing positioning solutions indoors, this actually represents a problem on how do you build the business models and how do you provide experiences that are valuable to the end user and are able to monetize on this technology like any company needs to monetize whatever they are doing in order to proceed and survive. So that's an important thing. And in practice, among the deployments that we have been making around the globe, I think that in every single one of those, the business model is such where the end user is not directly paying for the positioning capability. So if we give, for example, an example of a transportation hub, which could be a train station or which could be an airport or something like that, the user of an application that supports positioning in those spaces would not be paying for that application, but rather the application would be provided by the airline or by the airport operator or by the train line or something like that. So there's a big difference there.
Yeah, and I think this is also a really, really important consideration. Like, if at some stage we as a society decided that the global positioning system, was so important that we were going to make it, available to everyone that wanted to hook up to it. Could you imagine a time where we can see indoor positioning in the same way? And if we did decide to make this globally available, another piece of the global infrastructure, what would it take to do that? Because it feels very much like it's a case by case basis at the moment. Is there any chance of this being comparable to GPS in terms of that global coverage?
That's an excellent question. And of course, the way we see ourselves is that we are a company who has the technical capability to be that global player and to enable all of these different spaces. But like I mentioned here, we have a certain workflow that needs to be followed in order to enable the indoor positioning to happen indoors. And at the moment, there are no, or there's no single company that would be providing a solution that would be available everywhere. Of course, we have the large ecosystem players who are also part of this ecosystem. So you have companies like Apple and Google who have their own indoor positioning strategies. The Like you said there, there's value, a lot of value in being able to know where you are indoors, and that is something that enables many other exciting services and use cases when you have indoor positioning available and indoor location available. So those use cases are valuable, and therefore it makes sense for these to be available everywhere. But because the technological environment is much more challenging when you're indoors, so you can't do the equivalent of GPS, which would be just to have a fairly limited amount of satellites globally, then serving everybody, on the surface. But rather in buildings, you have to deal with the separate floors and so on. So there are many technologies that are available. None of them is the single one player. They come with different good sides and different bad sides. The reason why we believe in the geomagnetic technology is that the core component of the positioning is something that's already there. The geomagnetic field is something that's been provided by Earth itself. So in that sense, it's providing this infrastructure already as is.
Yeah, and when I hear you talk about the different challenges in terms of indoor positioning, I think it's both really exciting, and I think if I was a company in the space, it'd be really scary as well, because I guess the challenge is to provide so much value to the end user that companies are going to want to pay for this. Companies are going to invest in it, and they're going to create experiences or create journeys or value in some way for the end user that it's going to be able to be monetized. So they're going to get their money back on their investment in some way, shape, or form, whether that's in terms of branding, just providing amazing companies consumer service, or whether it's, I think, the classic path to monetization we've seen again and again is advertising. And personally, I hope we don't go down that road, or something else, something in the terms of the experience, which really sort of provides enough value that people say, hey, this is worth investing in, let's do it. And I think that that's both really interesting and really scary at the same time.
Yeah, it's very true, and I also think that it's a bit scary that you have these kind of technologies available that enable one to position or know where you are at all times. And of course, this is a problem that can be, or these fears can be managed and mitigated. So one has to sort of think about indoor positioning capability also in the context of privacy, and to be able to provide solutions that are secure so that your privacy and your positioning information is not compromised. I think that well, I have been myself in this business for roughly 3 years, so I consider myself still a newcomer. One of the sort of classical business models indeed is advertising and to have the proximity advertisement capability. I think it's easy to see how this could be also kind of disturbing. So you probably don't want to get notifications of advertisements on every step that you take. And if you did that, it's very likely that your users would be very unsatisfied and not run your application or service. So you need to find ways that are pleasant and the value is provided in a way that keeps people incentivized and motivated in using the applications and solutions.
Yeah, absolutely. And in terms of providing value, I can see something like this, saving people a lot of time, or giving those personalized experiences. You're standing at the checkout at the airport, your plane is cancelled. Where do I go next? It's a stressful situation. I think, we've all been there before. We've all stood at the checkout gate. Oh no, the gate's changed. The plane's leaving from somewhere else. Just as an example, of course, how do I get there? And you want a personalized experience at that moment. I want navigation designed for me at the moment, getting me from where I am now to where I need to be in a short space of time. I can imagine things like that providing so much value that people would be willing to invest.
Yes, exactly. And there's you mentioned sort of or alluded at least to stress levels, and I think that indoor positioning is certainly something that can really help in managing the stress levels. And we have deployments in hospitals, for example, where there are applications that provide the patients and the staff and visitors to the hospitals guidance and information where they are. And that's one way how actually this can be, or indoor positioning can be very powerful in that it can reduce your stress levels because now you can easily get where you need to go in time in a complex building like a hospital would be. And we also need to bear in mind that these buildings like hospitals and airports and almost any very large structure are of the type that they are kind of not static. They are changing. So departments change, and you mentioned the gates change. Well, gate changing is of course a very frequent occurrence in an airport, but even larger functions within a building can change, and this is where the digital positioning systems and digital maps really come in handy as they are able to easily adapt to changes and therefore provide a better user experience.
Eric, I really want to thank you for this fascinating conversation about indoor positioning, what it looks like today, and perhaps what the future of this might be. I think it's an incredibly fascinating space that you're working in, full of challenges. But I think it's going to be really, really, really interesting to see how companies like IndoorAtlas solve these problems in the future, and what kind of experiences we can expect in terms of indoor positioning and navigation. Thanks so much for coming along. But before I let you go, where can I go to learn more about you?
Yeah, thank you, Daniel. So you can easily just go to our website, IndoorAtlas.com, and you can find a lot of information and videos there directly. If you want to learn even more and go even deeper, you can register as a developer, and then you can get access to more videos, more documentation, example software, and so on. And that actually even puts you into a place where you can start to use our technology just like that by fingerprinting a place like your own home or any building and go from there.
Eric, thanks again for your time. I really appreciate it.
Thank you, Daniel.
And that's it for another episode of the Mapscaping Podcast. My name is Daniel, and I want to thank you again this week for tuning in. It's much appreciated. If you'd like to reach out to me for whatever reason on social media, you'll find some useful links in the show notes.